Hello guys, today we will be introducing the ellipse in the conic section. An ellipse is a regular oval shape traced by a point moving in a plane, so that the sum of its distance from two other points, the foci, is constant, or resulting when a cone is cut by an oblique plane that does not intersect the base. After saying all that, you might still don't get what an ellipse is, so I asked some professionals to teach you about ellipse. First of all, it's Professor Julian. Don't let his looks fool you, he's a master in ellipse.
The standard form of an ellipse and its degenerate form. The standard form of an ellipse has two formulas. One is when the major axis is horizontal and one is when it's vertical. The major axis is this red dotted line over here. The A stands for the radius, which is horizontal, and B is the vertical radius. C is the distance from the center to either one of its foci, and we can use this equation right here to find out either A or B. The parameters. A is the horizontal stretch, B is the vertical stretch, H is the horizontal shift, and K is the vertical shift. So as you see here, when H is 0, the center is on the y-axis, and when K is 1, y is 1. And if A and B are 1, then the distance or the radius is 1 unit. If I change this to 0, A to 2, B to 3, the center will move to the origin. The vertical radius would be 3 units apart, and the horizontal radius is 2 units apart. And the degenerate form of an ellipse is just a point with a radius of 0. So when all 4 of the parameters have a value of 0, we only get a point here.
Next up, we got Mr. Coca. Doesn't he look professional already?
So how can we determine if the equation in the general form represents an ellipse or not? Well, first we have to determine the general equation of the ellipse, which is ax squared plus cy squared plus dx plus ey plus f equals 0. So how can we determine if the equation is an ellipse? Well, there's some of the ways we can look at it. First, we have to look at the a and c value. The a and c values have to have like signs. For example, it can be negative, negative, or positive and positive. So remember that the c value is always the number that is before the value of y squared. And another point that we have to be careful of is that when we determine that it's negative, negative, or positive, positive, we have to look at the second step of how to determine if it's an ellipse or not. So let me erase this. So the second point we have to be aware of is that when a and c is positive, positive, or negative, negative, the value of a, c have to be bigger than 0. So that's the point we have to determine. We have to look at if it's an ellipse or not. Okay, now I'm going to use an example to prove the ways that I'm using. 3x to the power of 2 plus 5x to the power of 2 minus 4x plus 16. Let me erase. Equals 0. Okay, so we look at the a and the c value. The c value, is y squared. The c value is a number before y squared, and we look at the a value, which is 3, and the c value is 5, which is both positive. And then we determine if 3 times 5 gives us a number that is greater than 0 or not. So we recognize that 3 times 5 equals 15. And then 15 is bigger than 0. So we can conclude that this general form of equation represents an ellipse. So how do we use the concept of the ellipse to solve a real-world interesting problem? So here's our problem. A whispering room is one with elliptically arced ceiling. If someone stands at one focus, and so on and so forth, I'm not going to finish the question. So maybe you can pause this part of the video to read the questions, since our group is short on time. Suppose each gallery has ceiling reaching 20 feet. So each gallery has a ceiling reaching 20 feet is our information about the 5-foot high vertical walls at its tallest point. Suppose the foci of the ellipse are 30 feet apart. What is the height of ceiling above each whispering point? So we got many data from looking at the question. We got the height of the vertical walls and the ceiling that is apart from each other, which is 30 feet apart. So how do we solve? First, we have to determine our h and k value. And 5 feet or 6 feet would probably be the normal height of most individuals, enough for like talking and hearing above the floor. So we'll set our k value to 5, and our h value will be 0. In case some of you doesn't know where does the 5 come from, since the ceiling is half of an ellipse, and since the foci will be on the line between the tops, the foci will be 5 feet above the floor, which sounds about the normal height for people talking and listening. So we'll just use 5 feet as our number. So how do we solve the equation? We have our equation, which is b squared equals a squared minus c squared. And all we have to do is just plug our number in, which will give us 400 equals a squared minus 225. And our next step is to use the equation that is mentioned earlier in our video, which is the equation for our ellipse. So we just plug the number we found out into the equation. Let me erase most of the works. So our equation will be x minus 0 squared over 625 plus y minus 5 squared over 400 will equal to 1. Okay, so just in case the numbers are confusing, we got our numbers from the equation, which is 400 and 625, which is our a squared value. And now we have to find the height of the ceiling above the foci. So we will look at the height will be the y value of the ellipse when x equals 15. I'll erase some of the works. So we'll write 15 squared over 625 plus y minus 5 squared equals 400 equals 1. So we set our equation. The numbers are all from our question, which is from our questions, the 15 and the 625, which is our a value. So now we just solve this equation, and we will get we'll get 9 over 25 plus y minus 5 squared over 400 equals 1. And now we just solve the equation furthermore, which will simplify to 144 plus y minus 5 squared equals 400. And then we just solve our equation. We'll find out that y will equals to 21. And now we know that the ceiling is 21 feet above the floor, which is the height we want to find. And so that is the solution to our question here. Okay, and we got our solutions.
Wow, that was a lot of things to digest at once. But don't give up on us, because as we know, we save the best for last. Last but not least, we have Professor Andy. He is a professional in ellipse, and he's so mad that he can find ellipse interesting.
Hello, my name is Andy, and next up I would like to present to you about any interesting properties in ellipse and where can the ellipse be found in real life. First, let's start with interesting properties in ellipse. So now you may already know that there are 2 points in the ellipse which are called foci, and if you place any single point on the ellipse and connect it with a foci, so right here we have blue line and a red line. So now if you just drag the point on the ellipse, you will find out that no matter how you rotate, the sum distance of blue line and the red line will be constant in a way that even though in some situation where blue line must be shorter, but that also means the red line will be larger. Or in the textbook we know that the A stands for the 1/2 diameter of the major axis. So the sum of blue line plus red line will equal to 2 times A, which is the whole diameter of the major axis. Another interesting thing that I found is that there are 2 vertical lines called latus rectums. And it's basically the lines that you draw vertically that passes through the foci points. And we are able to find the distance of latus rectum by simply using this equation, 2b squared divided by a. The b means the 1/2 diameter of the minor axis, and the a means the 1/2 of diameter of major axis. So next, where are these ellipses can be found in real life? The first one will be football, American football, running track, a slice of a carrot, even cutting a carrot in different angles, which can also form an ellipse too, but the cutting angle must be greater than generator angle itself, and it must be less than 90 degrees, or else if it's a 90 degrees, then it will become a circle again. Satellite. Satellite is orbiting around Earth in not a perfect circle path. It can also be a planet's orbital path. By now, we should know that the Earth goes around the Sun, not in a perfect circle. So hope you all like my presentation. Thank you.
Thanks a lot, guys, for being patient and listening to us all the way. We hope we taught you something and that you are happy with our video. Thank you very much.